Hi everyone, good morning. Can you able to hear me and is my screen visible to you? Is my screen visible to everyone? Am I audible? Yes, fine. So in today's class, we are going to discuss the questions on aldehyde, ketones and acid. Okay, have you gone through? Have you revised this chapter? Have you revised this chapter? Yes, fine. So we'll discuss the PYQs on aldehydes, ketones and acids today. Okay, so moving with the first question. Okay, so look, this question, in the following reaction, P, Q, R, and S are the major products. Yes. So here, like a series of reactions are given. Okay, you have to identify P, Q, R, and S, and you have to choose the correct statement about P, Q, R, and S. P and Q are monomers of polymers, dacron and glyptyl. P, Q, R, and R are dicarboxylic acids. Compounds Q and R are the same. R does not undergo aldol condensation and S does not undergo Cannizzaro reaction. Okay. So first what you have to do is like find out the product. Okay. So we'll solve one by one. Like take the first compound. You're going to treat it with KMnO4 in presence of KOH. You heat it and when you do hydrolysis, you'll get the product P. Okay. So first we'll identify each and every product and then we'll come back to the statement. Okay. So moving with the product prediction. So for the first reaction, okay, so try out the product. You have a vinyl ring. Here one end is attached to a tertiary butyl group and to the para position you have ethyl group. So you have CH2, CH2. And here you're going to treat it with KMnO4, KOH, and you're going to heat it. And in the second step, you're hydrolyzing it. So what would be the product you'll be getting? So you have an alkane, is you have the side chain which contains the alkyl part. Okay. So what happens like when you put KMnO4? KMnO4 is a very good oxidizing agent. Okay. So here you are using a base. Okay. So which is an alkaline KMnO4. So when you put an alkaline KMnO4 to the chain, like what happens? It is aldehyde ketone chapter. Yes. So now when you treat it with like KMnO4, KOH, KMnO4 is a good oxidizing agent. Okay. So what happens over here is like this side chain will get converted into COOH. Okay. COOH. So the side chain it will get converted to COOH. Here you have like two side chain, which is here it is a tertiary butyl group. So due to the steric hindrance, right? So this part will get converted to an acid. So this tertiary butyl group will remain as it is and here it gets converted to carboxylic acid. Okay. So this is your P. This is P. So I got P. Okay. Now moving to the second reaction. So what is the second reaction given is in the benzene ring you have COCl and to its ortho meta position you have like COOMe. You are treating it with NaOH, H2O and you're hydrolyzing it. What would be Q? Okay. So write down the product Q. I'm writing down the second reaction. So what is the reactant? The reactant is you have COCl and to its meta position you have COOMe. So you have a ester group and the carbonyl halide. Okay. So you have two groups, acyl halide and the ester group. And you're treating it with NaOH, water, and in the second step, you're doing the hydrolysis. So what type of reaction will it undergo? What type of reaction will it undergo? It will undergo the aromatic electrophilic substitution reaction. Okay, aromatic electrophilic substitution reaction. So, which is a good electrophile over here, whether it is COOMe or COCl. COCl is a good electrophile. So here, what is going to happen is like you are going to remove this Cl. Okay, so NaCl will move out. So you'll be getting COOH. COOH. And here you have like COOM. So it is SNAE mechanism. Okay, so it will undergo substitution and aromatic electrophilic substitution will happen. So this is your Q. This is your Q. Now I got Q. Okay, I got Q. And third one is like you're having CN, CO, CH2, COOMe. You're doing the hydrolysis, and in the second step, you're treating it with H2CrO4. Okay, then write the product R. So third one is you have Cn and CO, CH2, COOMe. First step, you're doing hydrolysis. Okay, so here I have an ester. So ester on hydrolysis will give acid, right? So just write the corresponding acid. And here to cyanide group is there. So cyanide on hydrolysis will give acid. So both will get converted to acid. So you'll be getting COOH. And here it is COCH2, COOH. Okay. So this ester also is when it undergoes hydrolysis, you'll be getting acid and alcohol. So methanol will go out. And here cyanide on hydrolysis will give like NH3 will move out. So you'll be getting COOH. Cyanide gets on hydrolysis gives acid. Ester on hydrolysis gives acid. Okay. And then what you're doing is like you're heating it. When you heat it, what happens? Carbon dioxide gas will be evolved. Carbon dioxide gas will be evolved. So this CO2 will move out. From which one it will move? From the carboxylic acid, which is attached like when you take this ring. Okay, so this ring is like more it is like electron rich. This is C double bond O. It will have a partial positive charge due to the high electronegative atom of the oxygen. So this COOH will not undergo decarboxylation. Here this COOH is attached to CH2, so it will undergo decarboxylation to form an alkane. So CH2 will get converted to CH3. So you'll be getting a ketone, and this acid it will remain acid. Okay, can you got like why this happens? Clear? Yes. And what is the second step? After heating, after doing hydrolysis and heating, you're treating it with like H2CrO4. So when you put like H2CrO4, what you'll be getting? H2CrO. So what you'll be getting like this part will get converted to acid again. So you'll be getting COOH, and here you have CO. Okay, so this is your R. This is your R. Now, what is the last reaction? The last reaction is here you have like C phenyl ring where Br is attached, and here a dioxane ring is attached. You're treating it with magnesium. So when Br is there and when you treat with magnesium, what product you will be getting? Halide with magnesium in presence of dry ether. What will be the product? Like what reagent you will be getting? You have Br, and here you have a dioxide. Okay. So now we are treating it with magnesium dry ether. So when you have an halide, when you treat with in presence of dry ether, what will in the first step you'll be getting a Grignard reagent, you'll be getting MgBr. Yes, and this will be acids. Now what you're going to do? You're going to react it with what is the second reagent given? CO2. You're going to react it with CO2 and then you're doing hydrolysis. So when you react with CO2, what you'll be getting? You'll be getting COO-MgBr. Okay. So this part will be like COO-MgBr and this ring will not get affected. Now again you're doing hydrolysis. When you do hydrolysis, acid hydrolysis, here you'll be getting H and here it will be like OH. So what you got is like acid, COOH, oxygen and X. Okay, fine. Now what you're doing is, and when you do hydrolysis of this part will also change. Yes, so here like you have a CONGBr. So when you do hydrolysis, you got COOH. Okay. Now when you do hydrolysis of this part, what happens like the ring will break over here. So the ring will break to give. So this part will move out. So you'll be getting as CH. Okay. And then what you're doing is like you're reacting it with ammoniacal silver nitrate. So ammoniacal silver nitrate, when you put ammoniacal silver nitrate, this we have studied as the silver test, right? So what happens during the silver test? Which one will react over here? Like aldehyde group will react. So here you have an aldehyde group. So this will get converted to acid. So when you put ammoniacal silver nitrate, silver will get precipitated by oxidizing this aldehyde. So you'll be getting COOH, COOH. So it is your test. Now moving back to the statements. Okay, so we are going to find out like which statement is going to be right. P and Q are monomers of polymers dacron and glyptid respectively. Like can this one act as a monomer like P and Q? No. And second is PQ and R are dicarboxylic acid. Are they dicarboxylic acid? No. It is a monocarboxylic acid. It is also monocarboxylic acid. So option 2 is also wrong. Now moving to option C, Q, compost Q and R are the same. Like look on to Q and R. So it is a dicarboxylic acid at 1,3 position. It is also dicarboxylic acid, right? At what is the position over here? Whether it is 1,3 or 1, 2, 3. So it is like dicarboxylic acid at which position? It is at 1,4 position. Okay. So Q and R is not going to be same because here it is at like 1,3 position and here it is like 1,4 position. Okay. And R will not undergo. Okay. So the compounds are same like they are dicarboxylic acid. R will not undergo aldol condensation. Why R will not undergo aldol condensation? Because it does not have the alpha hydrogen. And S will not undergo Cannizzaro reaction. For S to undergo Cannizzaro reaction, for Cannizzaro reaction, no alpha hydrogen should be present. So no alpha hydrogen is present over here. So S will undergo Cannizzaro reaction. So option C and D are going to be the right answer. Okay, so got with this question, what you have to do is like you have to use the reagent and find out the product and look over the statements. Okay, clear with this question, everyone? Clear with this question? Shall I move to the next question? Yes. So moving with the next question. Okay, so here too it is PQ, R and S. You have to predict the product and find out the correct statement. Here you have to find out like whether they have the asymmetric carbon or not. Okay, so that is the thing what you're going to do over here. Okay, so now predict the product. You have a cyanide. Okay, so you have cyanide group here and you're treating it with PHMGBr. You're doing hydrolysis. What would be P? And then PHMGBr, then you're doing hydrolysis. So what would be P? What would be P? What would be P? Predict the reaction. What will happen when you react with PHMGBr? So this cyanide group, right? Cyanide is having C triple bond N, and here you have like PHMGBr, where MGBr will have a partial. What sign will be there for MGBr and what sign will be there for pH? So when you take cyanide, N is like more electronegative than carbon. So what should be the sign on nitrogen and what should be the sign on carbon? Nitrogen is more electronegative than carbon. So what nitrogen will do? It will pull the electron towards itself, right? So what will be the sign on nitrogen and what will be the sign on carbon? What will be the sign on nitrogen? It pulls the electron towards itself. So it will have a negative charge and carbon will have a positive charge. Yes, because nitrogen pulls the electron. Carbon gives the electron, so partial positive charge on carbon. Same way you can put like for pH MgBr. So Mg is a metal, right? So it will have a positive charge and pH will have the negative charge. Now what you have to do is like this nitrogen, since it is negatively charged, it will attract MgBr. Okay. And cyanide is positively charged, so it will attract pH. So what you'll be getting over here, I'll write the reaction in fresh page. Okay, so what I have is like I have CH3, CH2, CH, CH3, CH2, C triple bond N. It reacts with PHMgBr. Okay, so Mg is having negative positive charge and here carbon is having positive charge. So now what does this nitrogen will do? So this pH, since it is negatively charged, it will come to positively charged carbon and this nitrogen will take up MgBr. Okay, so now write the reaction. We have CH3, CH2, CH, CH3, CH2, C, and what will be attached to this carbon? You have the phenyl group, so pH. And what would be the bond between carbon and nitrogen now? Double bond N. So here nitrogen will take up MgBr. This is what you got. Okay, so this is what you got. Now what you're going to do? You're going to do the hydrolysis. Hydrolysis. So when you do the hydrolysis, what happens? The bond will break. Where the bond breaks, the bond in the double bond will break. So here it will break. You'll be getting H2. So what will be the product you'll be getting? You'll be getting CPH double bond. This will be the product. And here N will take up hydrogen, MgBr will move out. Okay, I'll write the major product. Now what you're doing is like, again, you're reacting it with PHMgBr. Again, I'm going to react it with PHMgBr. Okay, and you're doing the hydrolysis. Okay, so now when you again react with PHMgBr, again you have to like put negative charge and positive charge. Okay, so now like predict the product, write down in your notebook, put positive, negative. So this is positive, negative. And here like this is positive and this will be like okay. So now what happens? Again, you just shift up. This pH will go to the carbon and oxygen will take up MgBr. Okay. So therefore, you'll be getting CH3, CH2, CH, CH3, CH2, C, pH, So where this pH will go? It goes to the carbon. So pH, okay, and then it becomes a single bond OMgBr. Now what you're going to do is you're doing the hydrolysis, H plus OH. So oxygen will take up hydrogen and OH minus will go to MgBr. So you'll be getting CH3, CH2, CH2C, PH, PH, bond OH. Okay, so this is your first product, which is P, which is P. Now look over like it has any asymmetric carbon. Does P has any asymmetric carbon? What is asymmetric carbon? Chiral carbon, right? So does P has any chiral carbon? Does P has any chiral carbon? Yes or no? What is chiral carbon? What is chiral carbon? The carbon which is surrounded by four different groups are chiral carbon. Okay. So now, like, is there any chiral carbon? Is there like any chiral carbon? Or tell me, like, is this carbon chiral carbon? Is the first carbon chiral carbon? No, because it has like two pH groups. So it is not a chiral carbon. Here you have like two hydrogen. Here you have different groups. Here you have an ethyl group and CH3 hydrogen. And here you have a different group. So this is your chiral carbon. So I have like one asymmetric center. Okay, so P has asymmetric center. Same way you have to sit and solve like all the equation and find out whether it has the asymmetric center. Okay, fine. Now moving to the second equation. So what is this? Like it has benzene, PHH is nothing but phenyl ring attached to hydrogen is benzene. You are treating it with CH3COCl in presence of anhydrous aluminum chloride. Like what reaction is this? It is a naming reaction. Benzene plus CH3COCl in presence of anhydrous aluminum chloride. What reaction it is? Can you guess the name of the reaction? It is a naming reaction, right? What is the name of the reaction? Can you guess the name of the reaction? Very good. Friedel-Crafts. Friedel-Crafts acylation. Friedel-Crafts acylation. Okay, CH3CO group is there. So which acts as an electrophile here? Hydrogen. Hydrogen will take up Cl and it will move as HCl. So what you'll be getting here is like COCH3. Now what you're going to do? You're going to react with PHMgBr and do the hydrolysis. Okay, same thing what we have done over here. You're going to do it. So what will happen over here? So this is having a negative charge, positive charge, negative charge. So you'll be getting PHC and pH. This pH is from the Grignard reagent. Okay. O, MgBr, CH3. Now when you do hydrolysis, so hydrogen OH. So I'll be getting it as like P, C, PH, OH, CH will be the product. Okay. Now, does it have like any asymmetric carbon? Does it have any asymmetric carbon? Is Q is having any asymmetric carbon? No. Okay. So no asymmetric carbon because this carbon has two same groups. This carbon also has hydrogen. So no asymmetric carbon. So it has P has chiral center, Q has no chiral. So it is acyl. Now moving with R. So you have like CH3, CH2, COCl. You're reacting it with half of PHCH2 twice CD. Okay. And then you're going to treat it with PHNgBr and then you're going to do the hydrolysis. So what happens when acyl chloride is reacted with the alkyl cadmium? Acyl chloride, when it reacts with alkyl cadmium, what happens? Cadmium will take up chlorine and it will be removed as cadmium chloride. So the other is just going to attach with it. So you'll be getting as CH3, CH2, C double bond O. What is there? CH2P. Now what you're going to do? React with PHMgBr and do the hydrolysis. Okay. So again, just make it as negative, positive, positive, negative, and attach the group. So you'll be getting PHO MgBr CH2. Now what you're going to do is like you're doing the hydrolysis. So MgBr will take up hydrogen OH and it will remove. So you'll be getting OH over. Now, is this containing any chiral carbon? Does R has any chiral carbon? Yes. So it has a chiral center. This is your chiral center. So R is chiral. R is chiral. Okay. So now moving with last reaction. PH CH2CHO. Okay. What you're going to do is like react it with Grignard reagent. So when you react, so here it is like COH, you consider. So here you'll be getting PHONGBr. When you do hydrolysis, it will get converted to OH. Okay. So this we have done already. So I'm just simplifying it over here. And then you're going to treat it with CrO3. So what is CrO3? It is a good oxidizing agent. So when you put CrO3, this alcohol will get converted to CrO3 in presence of dilute sulfuric acid. So what happens here? It will get converted to the corresponding pH double bond. You'll be getting the corresponding aldehyde. And then what you're going to do is like you're treating it with HCl. So carbon compound in presence of HCl. What type of reaction will it undergo? It will undergo nucleophilic addition reaction, right? So what will happen over here? You'll be getting a cyanohydrin as the product. Okay. So oxygen will take up hydrogen. We'll be getting PH, CH2, PH, hydrogen. Oxygen will take up hydrogen to form OH. And this part will get converted to cyanide because it is a nucleophilic substitution, nucleophilic addition reaction. Okay. So OH will be added in one part and CN will be added in another part. I'll make CH over. Okay. Nucleophilic addition reaction happens. And then what you're going to do is like you're going to treat it with sulfuric acid. When you treat it with sulfuric acid, what will happen? There will be removal of water molecule. Okay, there will be removal of water molecule and CN will get converted to COOH. So what will be the final product you'll be getting? So you'll be getting it as like PH, CH2, carbon is there, you have a pH, and then the CN will get converted to COOH. Hydrogen will be there. So therefore, what you'll be getting, like, is there any chiral center? Is there any chiral center? Yes, I have a chiral center. Okay. So therefore, what would be the answer? You have to check the answer. pH like look over the statements. P and Q have asymmetric carbon. So is there like any asymmetric carbon on P and Q? No. Okay. Q and R have asymmetric carbon. Q and R have asymmetric carbon. Do you have like any asymmetric carbon in Q and R? So Q is like, it is a chiral. So it has symmetric carbon on it. Okay. P and R have asymmetric carbon is going to be right. Okay. P has asymmetric carbon. S does not have any asymmetric carbon. Do S have any asymmetric carbon? Yes, it has. Okay, fine. So this is how like you have to predict the product and do the reaction. If Grignard reagent is given, like you can just divide it. Okay, so when you have like R, Mg, X, this part will be like positive and your alkyl group will be negative. If you have a carbonyl compound, this will be positive, carbonyl will be negative. So just attach it and do the hydrolysis. Very simple, okay? When Grignard reagent is used. Clear with this? Clear with this question? Moving to the next question. Okay. Considering the reaction sequence given below, what would be the correct statement? So in this lesson, right, in this unit, like there are series of reactions only. You have to solve the reactions in order to get the question. Yes. So look at the first question. It is CH3, CH2, COH. When it reacts with Br2 in red phosphorus and when you do hydrolysis, you'll be getting T. T on reaction with, can you just get this compound? What is the name of this compound? Can you get like, what is this compound? Can you guess it? It is phthalic acid. Yes, very good. It is phthalamide, okay? Phthalamide, potassium phthalamide. Potassium phthalamide, yes. And we are reacting with NaOH. And when you do like hydrolysis, you'll get Q plus this compound. Okay, so first we'll solve and then come back to the statements. So what is given is CH3, CH2, COH. Then you react it with bromine in red phosphorus in presence of water. What reaction is this? Can you guess the name of the reaction? You have alpha hydrogen. You have alpha hydrogen. So acid which contains alpha hydrogen, when it reacts with bromine in red phosphorus, what is the name of the reaction? Very good. HBZ reaction. Okay, Helmholtz-Zelinsky reaction. So what will happen over here? Like hydrogen will take a Br and it will move out. So one Br will get substituted. So you'll be getting like alpha bromo, alpha halocarboxylic acid. So BrCOO. This is your P. Now, this P is going to react with potassium phthalamide. Bond O, and P. Okay, so N minus P. Now, what you'll be getting? What you'll be getting? N minus K plus. What you'll be getting? What would be the product? Can you imagine the product? So, you'll be getting like N double bond O, sorry, C double bond O, and here nitrogen is there. So now what does this potassium will do? Potassium will take a Br and it will be removed as KBr. So attach this carbon, you have CH3, COOH. This is what you'll be getting. Okay, so KBr will be removed. And you're going to react it with base. Okay, and when you do hydrolysis, what would be the problem? So when you react it with a base, what happens over here? And you're doing the hydrolysis. So here you'll be getting acid will get separated. So one of the product is already given in the question. Let's see. You have, okay. So it is 1,2 dicarboxylic acid you have. So that is what we are going to write here. So what would be the other products? I'll be getting COOH, COH. This is given in the question itself. So what would be like the other products? So here hydrogen will get added. So we'll be getting NH2, CH3, COOH. This is your Q. This is your Q. Now look over the statement and find out the answer. Okay, so you are having COOH. So going back to the statement, what is given here? P can be reduced to primary alcohol using NaBH4. So when you use NaBH4, okay, sodium borohydrate, will the P can be reduced to primary alcohol? Well, NaBH4, sodium borohydride, can be reduced, can be used to reduce the acid to primary alcohol. Will sodium borohydrate reduce acid? Will sodium borohydrate reduce acid? No. Okay. So it will do not reduce acid. Do not reduce. And second is treating P with concentrated ammonium hydroxide solution followed by acidification gives Q. Okay. So what is P? Here you have the P. Okay. So alpha bromo carboxylic acid. Now, when you treat it with concentrated ammonium hydroxide solution followed by hydrolysis, does it give Q? Does it give Q? So, what is Q? Q is this. Will it give Q? Is the question. So, when you treat it with like ammonium hydroxide. So, what will happen over here? And when you do the hydrolysis, like hydrogen will take a Br and it will be removed as HBr. One water molecule will go out. So what will be remaining? You'll be getting NH2COO. NH2COO. So same Q is obtained. So therefore B is going to be the correct statement. B is going to be the correct statement. And treating Q with a solution of NaNO2 in aqueous HCl will liberate nitrogen. So just imagine this is Q. What you're going to do is like you're going to react it with NaNO2 in HCl. Okay, that is, it is a mixture which is used to produce nitrous acid. Okay, so you have a primary amine, NH2. NH2 is primary amine. So primary amine on reaction with nitrous acid, what you'll be getting? N2 gas will get liberated. N2 gas will get liberated. So therefore, option Q, C is also right. And P is more acidic than CH3, CH2, COH. Is it true? Compare P. This is P. Is it more acidic than CH3, CH2, COH? Propanoic acid. Is it more acidic than propanoic acid? Yes or no? See, the group which is attached is like, it is a minus I group. So if minus I group is attached, what happens to the acidity? Will it increase or decrease? If minus I group is attached, okay? So will it increase or decrease the acidity of the compound? It will withdraw the electron. So the bond between carbon and hydrogen, like oxygen and hydrogen, will become weak. So H plus can move out easily. It will increase. Okay. So P is more acidic than CH3, CH2COH is also. Okay. So these the statements are clear with this question. Clear? Yes. Moving with the next question. Okay, so consider the following transformations of a compound P. Okay, so here P, whose molecular formula is C9H12, is converted to Q when you put a reagent called X and you're treating it with acidified KMNO4. And when you heat, you will get an optically active acid as the product. And when you react it with NaNH2, and then C6H5COCH3, when you do hydrolysis, you'll get R as the product, which is also optically active. When you react it with platinum hydrogen, you'll be getting this as the product. Okay. So now what you have to do is like find out what is P. And the following options are given as P is, the compound is given, R compound is given, what would be X is given. Okay. You have to find out the reaction. Okay. So first, we will find out like how this compound is formed, because this is only the known. This is known. Okay. when you do dehydrogenation with platinum, he will get converted to this compound. Now, what you have to do is like you have to do the dehydrogenation so that you'll be getting P, and the molecular formula of P is given. P is given. Okay. So how many carbon should be there? There should be like 9 carbon, and how many hydrogen should be there? Like 12 hydrogen. Okay. There should be like 12 hydrogen. Uh, you're doing the hydrogenation in presence of platinum. Okay. So using this, we will find out like what is P with 9 carbon and 12 hydrogen. So when I check over here, how many carbon you have? 6, 7, 8, 9 carbon I have. And the number of hydrogen will be here, it will be like more because here it is a single bonded compound. Okay. So whenever there is like addition of hydrogen, then there should be the presence of unsaturation. So a double bond or triple bond should be present. Okay. So now we are going to identify using the option. Using the option itself, we can identify. Like see, T is given in option A and in option C. You have to find out like which is going to be right. Which is going to be right. Okay. So you have a double bond at the same position. And here you can see like 1, 2, or starting from the ring alpha. So 1, 2, 3, 4. In the fourth position, I have CH2, CH, triple bond, CH. And here, 1, 2, third position, I have CH2, CH, triple bond, CH. Now, which is going to be right is the thing. Okay, you have to find out like from option A and C. So can you guess like which is going to be right? Which is going to be right? Whether A is going to be right or C is going to be right. See, here it is at like 1, 2, 3, 4. Now, when you make the number from here, it is going to be like 1, 2, and 3, and 3. Okay. So 1, 2, 3. Yes. So which is going to be right? Like C option. Option C is going to be right. This will be your P. Now, assuming like this is going to be P, I'm going to do the rest of the equations. I'm going to solve the equation to get Q and R. I'm going to evaluate. Okay. I'm assuming like this is going to be the P. Okay. Fine. So now we will find out Q using C as P. Okay. So write down what is given is this is your P. Now, in order to get Q, okay, in order to get Q, what is given? When you use a reagent called X, and in the second step, you're going to use CaMnO4, H2SO4, and when you heat it, you'll get Q as the compound, which is an optically active acid. And X is also given in the option. Okay, so X is also given in the option. So this is your X. This is your X. So what you're going to do is like, we are going to evaluate like whether X is going to be true or not. Okay, I'm going to treat it with, what is the X given? Palladium, carbon, or quinoline, or hydrogen. Can you like get the reagent? Can you guess what is the name of the reagent? You're doing hydrogenation in presence of the reagent. What is the name of this reagent? Can you get the name of the reagent? Can you get the name of the reagent? Palladium calcium carbonate you would have started. Very good. Lindlar's reagent. So when you put like Lindlar's reagent, What will be getting? Like cis alkene or trans alkene? So we are doing hydrogenation. Lindlar's reagent will give you cis alkene or trans alkene. Cis alkene. Okay. So you'll be getting a cis alkene. You'll be getting cis alkene. So now what you're going to do is like you're going to react it with KMnO4. Okay. So when you react it with KMnO4, that is acidified KMnO4, what would be the product? What would be the product? What you have to do, like break the double bond and you do the hydrolysis. Sorry, when you do, it will get converted to COOH. It is a good oxidizing agent, so it will get oxidized. So COOH will be the product. So this is what you got. So now what is given like Q is an optically active acid with the formula C8H12O6. So you have like 6 oxygen, 8 carbon and 12 hydrogen. You have to check like whether it is optically active. Is it optically active? Do you have like any chiral center in Q? Do you have like any chiral center in Q? Is it optically active? Yes. This is your chiral center. So you got Q. Okay. Now we are going to evaluate R. So same P when it reacts with NaNH2, soda amide. Okay, soda amide. So what will be getting when you react it with soda amide? When you react with soda amide, what you'll be getting? What you'll be getting when you react it with like soda amide? The acidified hydrogen will take up NH2 and it will be removed as NH3. So it'll be getting sodium salt. So here I'll be getting it as like C double bond C Na plus C minus. Okay. Now what you're going to do is like you're going to react it with PHCOMe. PHCOMe. Now this is your negative charge. Okay, here you have a positive charge. So what will happen over here? This negative charge will take up the positive charge to form. So I'll be getting C double bond C bond C bond O minus CH3PH. This is what I'll be getting. Now what you're going to do is like you're going to do the hydrolysis by heating it. So H3O plus hydrolysis. So when you do hydrolysis, it will take up OH. Okay. So it will take up OH. And here in the beta position, like you have CH2, CH3. So I'll make it as like CH2 hydrogen. When you heat it, what happens? Water molecule will move out. So you'll be getting C double bond C, bond C, PH. Here this water molecule will move out. So you'll be getting double bond CH. You'll be getting double bond CH2. This is your R. Now just we'll check R. R is like optically active. Is it optically active? Does R is optically active? Do you have like any chiral center? Do R is optically active? Do you have any chiral center? Yes, you have a chiral center. You have a chiral center. So R is also optically active. R is also optically active. So this is also optically active. Okay. Now going back to the statements. So we got like what is P? Yes. So is R true? No. Okay. We got R as you have like only one ring. Okay. You have like, sorry, 1 and 2 rings. C double bond C, C double bond CH2 you have. But you have a triple bond over here. So R is not true. And D is like we have used like palladium carbon in order to get the Q. So option B and C are going to be the right answer. Okay. So like in this question, you have to solve all the equation to get the answers. Moving with the next question. So here too, like you have to find out Q, R, and S. Q, R, and S. Okay. So like we'll solve it first and then we'll identify the compound. Okay. So here you have like Hg2 plus dilute H2SO4. So where does this reagent will be used? Where does this reagent will be used? It will be used to when you do the hydration. Okay, when you do the hydration, like in alkyne, when you do hydration in alkyne, we'll be getting this one. So when you do the hydration, we'll be using like Hg2 plus in dilute H2SO4. Okay, so oxymercuration happens. So what you'll be getting over here, you'll be getting OMe CHO. Okay, so you'll be getting OH double hydrogen. Okay, so now convert this into, it is in enol form. It is in enol form. Okay, when I convert this into keto form, what you'll be getting, like you'll be getting C double bond O. C double bond O. This is my keto form. Now, what is the second reagent you're going to use? This like you're going to use AgNO3. You're going to use AgNO3 in ammoniacal solution. It means that ammoniacal silver nitrate. Ammoniacal silver nitrate, which is your tolerance reagent. Which is your tolerance reagent. So what tolerance reagent will do? It will oxidize the aldehyde to acid. It will oxidize the aldehyde to acid. So this part will get converted to acid, COOH. Now what you're going to do is, right, you're going to use zinc amalgam concentrated HCl. Can you just name this reagent? What is the name of this reagent? Zinc amalgam concentrated HCl. What is the name of the reagent? Clemenson. So what Clemenson will do? Clemenson will convert the carbonyl compound to alkene. So what will happen over here is like you'll be getting CH2. Okay. So you'll be getting CH. So this part will be. Now this is your Q. I got Q. I got Q. Okay. Next is Q on reaction with thionyl chloride. Thionyl chloride. So where thionyl chloride is used? Thionyl chloride, pyridine. When you use thionyl chloride and pyridine, OH will get converted to C. Okay. So when you use thionyl chloride and pyridine, OH will get converted to Cl. Now you are reacting it with aluminium chloride. When you react with aluminium chloride, what will be the product you will be getting? Okay, it is not like anhydrous aluminium chloride, it is an aluminium chloride. So when you react with aluminium chloride, what you will be getting? When you react with aluminium chloride. So aluminium chloride, AlCl3, what it will do? It will take up the Cl and it will be removed as AlCl4 minus. Okay, if this is removed, you will be having a positive charge on the carbon. You'll be having a positive charge on the carbon. Okay, so now I'll just make this as a ring compound. Okay, I'll make this as a ring compound. So I can rewrite this as OMe C double bond O, which has a positive sign. And here you have like hydrogen. Here you have like hydrogen. Okay. So now this oxygen, okay, so this carbon will take up the hydrogen. Will take up the hydrogen. So therefore, you'll be getting like a cyclic compound OME double bond. Okay, so H plus will be removed. H plus will be removed. Now this is your R. This is your R. Now, when R on reaction with zinc amalgam concentrated HCl is again Clemmensen reduction. So here you'll be getting the S. Okay, so C double bond O will get converted to CH2. So OME, this will be the compound. C double bond O will get converted to CH2. This is your S. Okay, so now looking over the options, which option is going to be like right? So Q, here you have like OH, which is going to be wrong. And when you look into this option, so this is your Q. You have like Q and R, both are right. So option C is going to be right. And when you take like this one, this is your R, R and S. Okay, can you like check what is R and S? In R, you have a double bond over here. So this is also going to be wrong. Okay, so here you have like O. So D is going to be the right answer. Okay, so C and D are going to be the right answer. C and D are going to be the right answer. So this will be your R and okay, so clear with this question? This will be your S. So option C and D are correct answer. Clear with this question? Like all the series of reactions you're going to solve and find out the answer. Okay, clear? Shall I move to the next question? Shall I move to the next question? Yes. Moving with the next question. Which of the following reaction produce propane as the major product? So where you'll be getting propane as the major product is the question. So can you guess like where you'll get propane as the major product? Can you guess the reaction? Can you guess the product and write the product? In which among the, which are all the options will give propane as the major product? Okay, option A is right. Any other option will give propane as the major product? Very good. A and C. Very good. Okay, so we'll check the answers. So when you put with soda lime, okay, sodium salt on soda lime, what will happen? Na2CO3 will be removed. Okay, Na2CO3. This part will be removed. So hydrogen will be added. You'll be getting propane as the product. So 1, 2, 3 carbon. So propane as the product. So this option is going to be right. And here you have like you're doing the electrolysis. So when you do the electrolysis, sodium salt and electrolysis will give you RR. It means that you'll be getting hexane as the product. You have 1, 2, 3 carbon. Yes, again 3 carbon. So therefore you'll be getting hexane as the product. 1, 2, 3, 4, 5, 6. And when you treat with CH3, CH2, CH2Cl with zinc, can you like name this reaction? It is Frank-Plan reaction. So what happens over here is like zinc chloride will be removed to form propane as the product. CH2, CH3, CH2, CH2. And the fourth one is like you have dibromopropane. Okay, when it reacts with zinc, ZnBr will be removed. ZnBr will be removed. But you'll be getting a double bond. So you'll be getting propene as the product. So option A and C are going to be the right answer. Next is okay. So here you have a series of reaction and they have given you the product. Okay, STUSUTSU. They have given like 4 options. You have to find out like which is going to be the right one. For it, first we will solve it. Okay, C6H10O. On reaction with Grignard reagent, hydrolysis will give Q. Q on concentrated HCl will give S, which is your major product. And Q on reaction with 20% H3PO4 will give R as the major product. R again on reaction hydrogenation, nickel and bromine in HBr benzoyl peroxide will give you as the major product. Okay. So we are going to solve it. So first we have to identify like what is C6H10O. So C6H10. So it is going to be like a cyclic compound which contains one oxygen. So this is your C6H10O. Now we are reacting it with Grignard reagent, CH3MgBr. So here you'll have a positive, negative, positive, negative. So what you'll be getting is, you'll be getting ONGBr and CH3. Okay, so this we have done it already, Grignard reagent. Okay, same reaction. And then you're doing hydrolysis. So you'll be getting hydrogen, MgBrOH will move out. It will move out. So you'll be getting OH. So this is your Q. I got. Okay. So now what you're doing is Q is reacted with concentrated HCl. So when you react it with concentrated HCl, what would be the product you'll be getting? HCl on reaction with alcohol, like water molecule will be removed. So you'll be getting CH3C. So this is your, I got S. Okay. Now Q on reaction with 20% H3PO4. So H3PO4 is a good dehydrating agent. It is a good dehydrating agent. So water molecule will be removed. Alpha beta elimination will happen. So H2O will be removed. You'll be getting a double bond. And here it is like CH3, which is your R. Now R on reaction with HBr. Here peroxide is there. Peroxide is there. So what rule will it follow? When peroxide is there, you have a double bond, addition reaction will happen. So what is the product you'll be getting? What rule will it follow? You have alkene, you have HBr and peroxide. What is the rule you have to follow here? Very good. Anti-Markovnikov's rule. So what product you will be getting? The nucleophile will go to the carbon having more number of hydrogen. So here will be Br and here will be CH3. So this will be your U. This will be your U. And R on reaction with hydrogen nickel. So hydrogenation takes place. Alkane you'll be getting. Right? Double bond will get reduced. Again on reaction with Br2 H mu. So what is the product you'll be getting? There are like, you'll be getting Br. Okay, this is like one product. Here, in the hydrogen, Br can get substituted. So this is like one product. Another product could be on the CH2. Okay, in the CH2. So you can also get like Br. This is your second product. This is your second product. And also you can get it on CH2Br. So you have to count like how many different environment hydrogen are there. That many amount, that many product will be formed. That many product will be formed. Okay. And also like you can also get like Br. Okay. So many products are formed. Now, which will be the major product? Which will be the major product here? Which carbocation is going to be like more stable on this carbon only? So this will be your major product, which is because here major product is asked. Okay. So now we got like all the products. So just evaluate by looking into the options. Just check the options and mark the correct answers. So S and T are given. So what is like S? S should be like it is like completely having alkane only. No alkene is there. So it is not going to be the right option. When you check this, you have like CH3Br, which is your U. Yes, U is right. And what about like answer? Yes. What about like S? S is you'll be having CH3Cl over here. So this is also wrong. Okay. Now moving with the option C. So you have like CH3Br, which is U. U is right. And what about T is also right. So this option is going to be right. A, B, C, D. S. Is S true? Yes, it is true. Is U true? Yes, it is true. So this is also right. So C and D are going to be the right answer. Okay. So it is like very simple question only, even though like it is found to be like you have to find many products, but look over the reagent. What is given is like very simple. You can do this question easily rather than the questions what we have seen before. It seems to be like quite difficult because you have to sit and solve like each and every reaction and find out the correct statement. Here you are predicting the product and the reagent. What is given is like simple, so you can do this question easily. Okay. Yes. So moving with the next question. So in this question, you have like product is given. You have to find out the reactant. The reagent is given like PBr3, EG twice O, NaIMe2CO, NaN3, HCO, and Me twice. So when X reacts with these three reagents, we'll be getting this as the product, which is an enantiomerically pure product. You have to find out like what would be X. What would be X is the question. Okay. So now, in order to get this enantiomerically pure product, when you see here, you have Me, which is like towards, and any thrice is like away from the carbon. Okay, so this is like towards and this is like away. So using this itself, like we can predict it. Okay, so when I take like this one, okay, here like one is towards, the other one is away. Okay, so when I take like option A, when I take like option A, now when you react it with like PBr3, okay, will it undergo like SN1 reaction or SN2 reaction? What reaction will it undergo? SN1 or SN2? SN1 or SN2? It can undergo SN2 reaction, right? So tertiary carbocation will undergo the SN1 reaction. So it can undergo SN2 reaction. So when it undergoes SN2 reaction, whether inversion of configuration will happen or retention of configuration will happen. Which will happen? Inversion of configuration or retention of configuration for SN2 reaction. Inversion. So this is like away from. So therefore, what you have to get it like towards you have to get. Okay, you have to get it like towards. Yes, you have to get it like towards. So now again, when you react it with like NaI CH3COCH3 in presence of acetone, again it is going to be like SN2. Again, this is also going to be like SN2. So 3 SN2 should be there. So therefore, here it will be like inversion, inversion, inversion. So at last, you'll be getting the inversion product only. So here, this part, it should be like towards. But here it is given as inverted. So option A is going to be like wrong. But when I look into the option B, here it is like inversion. Okay, so when inversion happens, it is like towards and it is like away. It is like away. Okay, in option C is like away. So therefore, this option is going to be the right one. It is going to be the right one. Okay, and when you move to the option C is also like it is towards and away. Okay, it is like towards and away, but see, the ring is like tilted. The ring is tilted. Okay, so like you take only A and B, consider A and B alone. Okay, you consider A and B alone. It is a single question, single answer correct question only. So when you consider like A and B, I'll do the reaction. OH is there. Now, when you put like SN2 reaction, what you'll be getting? I'll have Me, which is in wedge bond. So Br will be in the dash bond because inversion happens, SN2 reaction. Again, when you put like NaI, it will also undergo SN2, NaBr will be removed. So inversion of configuration takes place. So what will be like, this bond will get inverted, so you'll be getting like two bonds. Again, when you react with Na and 3, what will happen? NaI will be removed. It is also an SN2 reaction. So again, what will happen? Like inversion of configuration takes place. So this wedge bond will again converted to dash bond. So when you take like option B, you are getting this enantiomerically your compound. So option B is going to be the right answer. Okay. So got this question? Screen is blank. Okay, is it visible? Is my screen visible now? Is my screen visible? Okay, fine. Okay, so got this question, everyone? Like by checking the uh, configuration, like whether it is like towards or away, you can easily answer this question. Okay, so next question is the reaction which is leading to the formation of 1,3,5 trimethyl benzene. What is 1,3,5 trimethyl benzene? So 1,3,5 trimethyl benzene. Okay, which is methicillin. Methicillin. So which among the reactions will give this methicillin as the product is the question. Can you guess the answer? Can you guess the answer? Which among the following will give methicillin as the product? Can you guess the answer? One three five trimethyl benzene. So when I take like this 3 times, okay, when you treat it with concentrated sulfuric acid, we know it is a good dehydrating agent. So alpha beta elimination will happen. Yes, so alpha beta elimination will happen. So write the enol form of it. We'll be getting double bond hydrogen, and here it will be like CH. CH. Okay. I'm writing the enol form. I'm writing the enol form. So when you write the enol form, you'll be getting like OH double bond CH. OH double bond CH. So when you are taking it 3 times, you are taking it 3 times. Okay. So what you'll be getting is like you'll be getting methicillin as the product. So when you write it as like 3 times, you'll be having 1, 2, and 3 carbon over here. Okay, 3 carbon you'll be getting 3 carbons. So here you have like CH3, which is the CH3 of this part. Okay. Now again, when you like repeat it, you'll be getting OH CH2. Okay. So now what happens is like dehydration takes place. So water molecule will be removed. Water molecule is removed. So you'll be getting like methicillin as the product. CH3, CH. Okay, so when I take this one, when you heat it in red hot iron, you have a CH3 group. So we know that when there is like acetylene, when you put in red hot iron, you will be getting benzene. Here CH3 is there, so therefore you'll be getting methicillin as the product. CH3, CH3. Now, when you take like option C, option C. So option C, what you're doing, you are reacting it with Br to NaOH. So when you react it with like Br to NaOH, what will happen? Here you'll be getting like O minus, this one will take up. Okay, so therefore you'll be getting like ONA and sorry, C double bond O, and here it is like CH3, right? Here you are having CH3. So hydrogen Br to NaOH. So when you put like Br to NaOH, when there is a carbonyl compound, when there is a carbonyl compound over here. Okay. So what reaction is this? This is a haloform reaction. It is a haloform reaction. So what you'll be getting? You'll be getting an haloform like CH. What is haloform? CHX3 is haloform. So haloform will get precipitated. Okay, haloform will get precipitated. So CHX3 will get removed. So you'll be getting ONA in all the things over here. So you'll be getting ONA, ONA. Okay, and then what you're doing is like you're doing hydrolysis. So if you do hydrolysis, then it will get converted to hydrogen. So when you do hydrolysis, you'll be getting OH, OH, OH. So you got acid. So when acid is treated with soda lime, decarboxylation happens. So this part will get completely removed. You'll be getting benzene as the product. The product will be benzene. Okay. And the option D is you're treating it with like zinc amalgam HCl. So when you treat with zinc amalgam HCl, what you'll be getting? You'll be getting CH3, CH3, CH3. So this C double bond O will get converted to CH2. So option D is also going to be. Okay, got with this question? Everyone got with this question? Yes. Fine. Okay, so moving with the, we'll solve a few numerical questions. Okay. Okay, so look over this question. In the following reaction, compound Q is obtained from compound P via an ionic intermediate. Okay. So P is given, you are getting Q. What is the degree of unsaturation Q? Here you are going to solve the equation and find out the degree of unsaturation. Okay. So can you get, what would be the answer? P on treatment with concentrated sulfuric acid. So when you put like concentrated sulfuric acid, okay, you're getting Q, which is a colored compound you're getting. So when you put like concentrated sulfuric acid, what will happen? Here you have C double bond O bond CH3. Okay. So when you treat it with like concentrated sulfuric acid, so this part will be, here you have a phenyl ring and C6H5, C6H5. Okay, so what happens over here is like coupling reaction happens. Okay, so here this part will be completely removed to form a positive charge. So this carbon will go and attack over here. I'll be getting like C6H5, C6H5, and can you guess the name of this compound? Anyone? Can you guess the name of the compound? It is a colored compound. Can you guess the name? Okay, so what is the degree of unsaturation is the question. Okay, what is the degree of unsaturation? So how will you do with the degree of unsaturation? Count the number of rings. Okay, so how many ring you have? You have like 1, 2, 3, 4, 5 rings. So you have like 5. And how many pi bond you have? So 3, 4 into 3 plus 1. So it is going to be 10. So total is going to be like 18. So the degree of unsaturation is 18. Yes, 18 is going to be the right answer. 18 is going to be the right answer. Okay, clear with this question? Fine. We'll solve like one more numerical question. Okay. So in the following reaction sequence, the amount of D formed from 10 moles of acetophenone is. The percentage yield of the corresponding product is given in each parenthesis. You have to find out the D from 10 moles of acetophenone. So I'm taking this acetophenone as 10 moles. So when acetophenone reacts with NaOBr in presence of H3O plus, what you'll be getting the reaction like what we have done it already. You have CH3 over here. You have CH3 over here. Okay. When you react it with like NaOBr, so this Br will take up this CH3 and it will be removed as CH3Br. CH3Br. So this whole part will get here. What you'll be getting is like CH3Br is removed. So what you'll be getting? You'll be getting ONA. Be getting ONA. Okay, CH3Br is removed. Now what you're doing? You're doing the hydrolysis. So if you do hydrolysis, you'll be getting alcohol. So this is your A. What is like 60% of A you have got. Okay, you have got like 60% of A. And when you're treating it with like ammonia, what is the product you will be getting? When you're treating it with like ammonia. Okay, so CH3Br is removed. Fine. I'm sorry, it should be like C double bond OH, please. So when you treat it with ammonia, acid on ammonia will give amide, right? So H2O will be removed. We'll be getting C double bond O NH2. So what happens over here is like H2O will be removed and NH2 will get substituted. So we'll be getting amide as the product, which is your B. This is, so a B is like amide. And then what you're going to do, you're going to react it with Br to KOH. So when you react with Br to KOH, what will happen? You'll be getting NH2 alone. This is an amide, okay? So amide, can you guess the name of the reaction? Br to KOH? Hoffman bromamide degradation. Hoffman bromamide degradation. So one of the carbon will get reduced. Okay, you're removing CO. Very good. So you'll be getting aniline as the product. So C is going to be like aniline. And you're taking Br to KO. Br to 3 equivalents in presence of acetic acid. So when you take like Br2 in presence of acetic acid, what you'll be getting? You'll be getting the electrophilic substitution reaction. Bromination will happen. Br, D. Okay, now I got like A, B, C, and D. What is the question? The percentage yield corresponding to the product in each step is given in the parenthesis. You're going to find out the amount of B from 10 moles of acetophenone. Okay, from 10 moles of acetophenone. So what I can, like A is 60%. So 60 by 100 into 50 by 100 into C is 50%, 50 by 100 into 10. Okay, into 10. So it is equal to how many moles? 1.5 moles. We'll be getting it as like 1.5 moles. So amount of D is equal to. So find out the molar mass of this one. Okay. into 1.5, you'll get the answer. So you'll be getting it as like 330 into 1.5, which is equal to 495 grams will be the, okay. Got with this question? Fine. So in this unit, like you could have seen, few questions are like very familiar reagents. Okay. If you're familiar with the reagents, you can solve these questions easily. Okay. So like simple reagents only it is given. So like you have to go through all the naming reactions first. If and go through like which will undergo oxidation. If alcohol undergoes oxidation, what will happen? So how aniline is formed from nitrobenzene. Okay, reduction happens. So like go through all the naming reactions once. So if the naming reactions is done, then you can go with the series of reactions. Okay. So like same way, you can expect the questions from Amin's unit also. So in Amin's unit also, like they will be giving the series of reactions, and you must like solve the question in order to find out the answer. Yes. Yes, I'll tell you the topic for tomorrow. One second. So practice many reactions for this part. Okay, for the organic part, you have to practice many reactions. So you'll get an idea. Like then only like everything will be in the mind. Keep on revising. Keep on revising by solving the questions. So tomorrow's topic is amines. Amines. Okay. So tomorrow we'll solve questions on amines. Go through the topic once and come back. Okay. So revise the topic once. Revise the whole chapter once. Go through the important reactions. Go through the naming reactions once and come back. So we'll solve the questions based on. Fine. Okay. So thank you all.